Greetings. This is the video to accompany my submission for the graduate assignment number 1 for the Introduction to JavaScript class. I have decided again to pursue option number 3 to prove our understanding. The graduate submission I'm going to make is a little bit more complicated and more interesting version of my extra credit submission. I have decided to, and let me just demonstrate this first. I have always been very inspired by the optical art of Viktor Vasarely. And what I have decided to do, and I've done the preliminary work for this in previous in previous times. What I've decided is I've decided to use the random number generator functionality within JavaScript to generate a randomized optical art. So I'm going to quickly demonstrate. When you press the Generate New Op Art button, every time the computer is going to generate a new op art in the spirit of Viktor Vasarely. And here you see a measure of the complexity of this artwork. Here there are 50 circles that are overlapping. And op art basically means that you never color two adjacent regions with the same color. So if it is black, the next one has to be red, etc. You have the option here to increase the complexity by pressing this button. Every time it's going to add 10 more circles, and the complexity each time is going to increase. And I have decided that probably 150 circles should be the maximum complexity allowed for these op art. You could also decrease the complexity. Every time you're going to have less and less number of circles, and the op art is going to get a little bit less complex each time. And hopefully the rendering time also picks up when you have less and less circles to process. So what I'm going to do is I'm going to quickly, so here we have 20 circles, 10 circles. You see the complexity is much less than before. So what I want to show is the code that went into this. And I want to start by showing, first of all, the HTML that went with this work. I have again utilized the button tags that I have explored during my extra credit submission. Here we have 3 buttons. One of them is for generating new op art, and the other ones are for increasing and decreasing the complexity of the artwork. So those buttons are created here. Then I have my canvas element. I gave it some dimensions, 1200 pixel by 600 pixel. And then this is the invocation for the JavaScript file. And the JavaScript file looks like this. First we have, we initialize our complexity. And by complexity, I just basically mean how many circles are overlapping in the diagram. I initialized this to 50 circles. I felt this was a good middle range complexity of overlapping circles. And as soon as we initialize the complexity parameter, we generate new op art. We call the function generate new op art so that when the page loads, the user does not see a blank page. And again, here we have increasing and decreasing complexity functionality for the buttons. And increasing complexity basically means every time adding 10 more circles to existing circle number. And decreasing means every time removing 10 circles from the existing circle number. The code for generating the new op art is here. We first access the complexity parameter, and we display it so that our user is aware how many circles are at each time being processed. So here you see 20 circles, 30 circles, etc. And this is being reported to the user by this assignment here. We assign to the element whose ID is complexity, its inner HTML, we assign it the current complexity value, which is the number of circles. Then we access the canvas, and here is where we assign random coordinates and radius for the circles. So we create X, Y, R arrays. These are going to be the X, Y coordinates of the center of the circles, and R stands for the radius of the circles. And what we do is we assign a random X value, random Y value within the canvas width and height. And we also create a random radius size. I have decided that the maximum randomly assigned radius should be about 200. This was just a purely, pure random choice, pun intended. And then we have, again, 2 for loops that does the magic. And what we do is we go pixel by pixel for all the pixels in the width and the height. What we do is we inquire whether that pixel, in how many circles does this pixel lie in of all those overlapping circles. So let me just give an example here. Imagine I'm right here at this point. I ask the question, how many circles encompass this point? In this case, none. But if I was, for example, here, the answer would be 1 here, 2 there, so it would be 2 here. Here it would be 3, etc. So what I'm doing in the code is I'm basically asking the question whether the pixel is in any or how many of those circles it is encompassed in. And based on that, I'm just doing a overlapping count. Now, if the overlapping count is even, I decide to color that particular pixel red. Otherwise, I color that particular pixel black. There is a theorem in topology that I'm actually using here from my study of mathematics, which basically says that if the number of overlapping circles is even, if you color it with one color, if the number of overlapping circles is odd, you color it with another color, then this entire diagram is too colorable. I'm just using this pretty well-known fact from mathematical graph theory. But that's not really important here. But the important thing is I'm using a for loop twice, double for loop, to check every pixel and basically checking whether if that particular pixel satisfy a particular set of conditions. Alrighty. Meow, meow, meow. Forgive my cat. I apologize for the cat interrupting this. I hope you enjoyed this, and I hope this was interesting. I will do one more round of these so you can see every time the increased complexity button is pressed, a more complex and in some ways more interesting diagram is created. And this is dedicated to Viktor Vasarely. Thank you for watching.